Lesson 6-8, Systems of Inequalities. Our essential question is, how do you solve a system of linear inequalities? A system of inequalities is very similar to a system of equations. So the system of inequalities we are going to solve just like we solved by graphing with the system of equations. What you need to remember though is that the differences between inequalities and equations involve whether your line is solid or dashed and shading one side of that boundary line. So this is kind of a review of something that we did in chapter 5, but in chapter 5 we only graphed one inequality at a time. So a system of inequalities would be two or more linear inequalities. And then the solution to a system of inequalities would be the region shaded by all of the inequalities in the system. Our first system of inequalities involves y is less than 2x plus 2, which I will graph in red, and y is greater than or equal to negative x minus 3, which I'll graph in blue. So for my red inequality, the intercept is 2, so on the y-axis I graph the intercept. Then if I make that slope a fraction, it's 2 over 1, so I'm going to rise 2, run 1 to the right, rise 2, run 1, and I'm going to continue this going in both directions because I'm not certain where these lines will intersect. So I'm going to cover the entire coordinate plane. You may recall, or you may not recall, that the less than symbol indicates a dashed line for us, and it would be shaded below, because less than, if you think about where on the y-axis where our intercept was, less than that intercept would be below it. So dashed line shaded below would look like this. Now for my blue line, I start at the intercept of negative 3, so negative 3 on the y-axis. And my slope, if it's negative x, I can put a 1 in front of it, so it's really negative 1x, and make it a fraction, negative 1 over 1. So my rise over run is going to be going down 1 over 1 to the right, like this. Again, I'm covering the entire coordinate plane, because I really like to see where my lines intersect. And this symbol is a greater than or equal to, so that's going to be a solid line and shaded above because it's greater than my line. So solid, and then shaded above that line. So you can see the region that has been shaded twice is the region that's over on the right-hand side where you see the red and blue squiggles. Now, we need to answer the question where it says to name an ordered pair that is a solution. Well, any point in this region here that's been shaded red and blue would be a solution. So I'm going to name one ordered pair, and this one looks good to me. So my ordered pair that is a solution is 3, 2. And that's just one of an infinite number of solutions that we could name there. So 3, 2 is the solution that I have chosen. Okay, our next system has two inequalities that happen to be written in standard form. So they're going to require a little bit of work before we can graph these. So please remember that we need to isolate the y. So I'm subtracting x on both sides, keeping it in slope-intercept order. And the negative in front of y means -1, so I divide everything by -1, which flips my symbol. And a negative divided by a negative is a positive. Positive divided by a negative is a negative. So y is less than x minus 5. So -5 is my intercept. My slope is +1. So rise 1, run 1 to the right. So here's my boundary line. The less than symbol is dashed and shaded below, like that. My blue inequality, again, is in standard form, so I will subtract 2x on both sides and keep it in slope-intercept order. Divide everything by 3, and y is less than or equal to -2/3 x minus 2. So my y-intercept is -2, and my slope is -2/3, so down 2 over 3 to the right. This symbol is less than or equal to, so it is going to be a solid line, and less than is shaded below, so shaded below. So now the bottom section is the one that was shaded by both of my inequalities. So the solution region would be anything in this bottom region that's been shaded blue and red. So to name an ordered pair that's a solution, I will pick this point right here in my doubly shaded region, and that ordered pair would be 2, -6. So 2, -6 would be one of the solution points. So anything in that shaded region. You could even pick a point that's on the blue line over here, like these points are solutions. You cannot pick one that's on the dashed red line though, because that's open, so it's not including the boundary line. Okay, example number 3. These two are ready to graph. So my red line starts at an intercept of +1. And the slope is -3/1. The symbol is greater than or equal to, so this is going to be a solid line, and greater than is shaded above. My second one has an intercept of -2, and the slope is -3, so down 3/1. So you may notice that these lines are parallel. Less than or equal to is going to be a solid line again. And less than this blue line, if I look at where the y-axis is, less than that intercept is going to be below it over here. So, name an ordered pair that is a solution. I do not have any ordered pairs that have been shaded twice. There's not a region shaded twice. So, this is an empty set. There is no solution. There's no solution. So, I should not see anything at all that's shaded twice. So this is an empty set. Now, just because the lines are parallel with inequalities, it isn't always going to be an empty set. So please don't stop and, skip the problem and just say it's an empty set because they're parallel. You'll see why on this next example. So on this next example, my first inequality, I need to divide everything by 2 because it was almost in slope-intercept form. I can graph this one, starting at -3, up 2/1. It's going to be a dashed line because the inequality symbol does not have an equal underneath. And it is greater than, so greater than is shaded above this line, like that. My second inequality is in standard form, so I need to subtract 4x. And then divide everything by -2, which we recall flips the symbol around and gives me a positive 2x minus 6. So this is parallel to my red boundary line, but you should see that we're still going to be shading. So I started at -6 for my intercept, and I'm going up 2/1, just like my first boundary line. And this one is going to be a solid line. And it's greater than or equal to again, so I would be shading above the line. Here's the thing. If I shade above this line, look at what happens. My solution is the piece that is shaded twice, that is shaded by both of my lines. So I actually don't want it shaded in between the 2 lines because that's shaded only by my blue. So I'm going to see if I can undo my shading and instead just shade the piece that's shaded twice, like that. So in between the blue and the red boundary lines, you should not be shading. You should only be shading the first one. So our solution set, when we put these 2 inequalities together, is actually that first inequality alone. Okay, so this is kind of like when we graphed on our number lines and we had 2 rays going the same direction, our compound inequalities. It's similar to that. So now, to name an ordered pair that's a solution, I can name anything that's in that doubly shaded region. So I'm just going to go with 0, 0 right here. So 0, 0 is going to be my solution. So anything that's been shaded twice. Now, you quite possibly could see multiple choice questions on your MCA or MAP tests. And this is a multiple choice question where they've graphed the system for you. And if you take a look at the graphs, they've got the lines graphed the same on all of these answer choices. So really what it comes down to is the shading piece. Okay? So you've got a couple of options to figure out which one is correct. And what I am going to do is I am going to use the idea of a test point, and I am just going to take a point in the region that they have shaded twice and test it to see if it's true for each of these inequalities. So my favorite point to use is 0, 0, and I noticed that on letter A, that is part of the green, blue and yellow make green, the green shaded region. So if I substitute into both of these inequalities, 0, 0, I am going to see if that is in fact a solution. So 0 plus 0 is greater than -4. 0 is greater than -4, that's true. 0 plus 0 is greater than or equal to +4. 0 plus 0 is 0. Is 0 greater than or equal to a +4? No, that's false. So I know that letter A cannot be the correct answer. So it is not that region that should be shaded. So I will check another one. Let's say I'm going to check, so that first one came out true. So that first one, I know the dashed line is supposed to be shaded above now. So it does not appear to be shaded above on B or C. So I'm going to check out 0, 0 on, not on D. That wouldn't make sense. That's not in my green region. So I'm going to pick a new point. How about 3, 1? 3, 1 is the new point that I'm going to use. So 3, 1, so that means x is 3 and y is 1. So 2 times 3 plus 1. So 6 plus 1 is greater than or equal to 4. That's true. 7 is greater than or equal to 4. And then in this one, if I put in my 3 and my 1, 3 plus 2 is greater than negative 4. Also true. So I have found my solution. My solution is D. So your test point, if you pick a point that's in the doubly shaded region, so I picked a point that was in the green region. I tried A first. It was not true for both of the inequalities, so I eliminated that answer choice A. I used the knowledge that this test point was correctly shaded for the dashed line, for this inequality. So I went with the assumption then that that inequality was supposed to be shaded above. So then the other one that was shaded above was D, and that one came out to be true for both. So D is the correct answer. Now, our last problem, this is another one that you could see on a standardized test. Name a point that would be a solution to the system of inequalities that you see graphed. So, anything in the green region. You can name any ordered pair in the green region. So, I'm going to choose this point right here. So, 4, 1 is one of the solutions. You could choose any point in that green region. So, maybe you like 5, negative 2 better. 5, negative 2, also in the green shaded region. There's an infinite number of points that you could select. You should be able to write your summary now, and here are your homework problems. There are not very many of them, so please make sure that you draw them and you take your time and your graphs are accurate.